Hi, Assalamualaikum and a very good morning. So now we are in chapter 7, which is Haloalkane, and we're going to focus on the subtopic of 7.2 chemical properties, part 2 of the video. So in this video, we're going to explain the elimination reaction of haloalkane, where we're going to focus on the dehydrohalogenation of haloalkane, where it means that if we remove hydrogen and also remove halogen from the system, for example, bromine atom and hydrogen atom. For part H, we're going to explain the use of the haloalkane in the synthesis of Grignard reagent. So haloalkane tadi akan digunakan untuk menghasilkan Grignard reagent, where it is indicated by RMGX or aromatic MGX, where Mg refers to the metal. For last part, we're going to use and describe the usage of the Grignard reagent in the preparation of alkene, alcohol, and the carboxylic acid. Okay, so from the Grignard reagent that we have produced, we're gonna prepare three important stuff, which is alkane, which is in A, alcohol B, and carboxylic acid C. Okay, we're gonna look that in the later slide. So without any further ado, let us start. So for the elimination reaction, we're going to focus on the dehydrohalogenation. So dehydrohalogenation means that it is a removal of halogen and a hydrogen from an adjacent carbon to form a carbon-carbon double bond in the presence of a strong base, for example, the hydroxide ion. Okay, so from an alkyl halide, the H and Br are going to be removed from the system, and this carbon single bond going to be a carbon-carbon double bond in order to produce an alkene. And as a result, the HBr going to be removed as a byproduct here. So these are another example of the elimination reaction. So this is our haloalkane, and this is going to be our strong base. So the strong base here is CH3, CH2O minus, and Na plus going to be the another ion. So this strong base here going to remove hydrogen and halogen from the system. So first we can remove Br and hydrogen from this side. And this is going to produce a product of CH3 dash CH double bond CH and CH3, which refers to CH3 here. Okay, and if you don't want to remove that, you can also do another possibility where you can remove this Br here and this hydrogen here. So if you remove on this side, you will get another kind of product where we'll get CH2, which is here, CH, CH, CH2 and CH3. Okay, and this is going to produce two types of product, which is the major product and the minor product. Okay, so these are going to be our major product and this is going to be our minor product. This is going to be our major product because it is a more substituted alkene, because this carbon-carbon double bond is attached with 1 and 2 alkyl group. Meanwhile, for here, it's going to be attached with only 1 alkyl group. Okay, and this follows the Sazaf rule as what you have learned in the chapter of alkene. Okay, the similar step happens for this situation where you have another haloalkane here, and when you're going to react that with a strong base with the presence of ethanol, so this one is ethanol in the condensed form, with heat, what you're going to do is you're going to get two types of products. So you can get you can remove Br and hydrogen here in order to get this product here, or you can remove Br and hydrogen here in order to get this product here. Okay, so we're going to follow the major, we're going to follow the Sazaf rule again in order to determine the major product. So this is going to be our major product because it is the carbon-carbon going to be attached with 1 and 2 and 3 here. So 3 substituted alkene with 3 alkyl group. However, for here, it's going to be attached with only 1 alkyl group. Okay, the whole thing here. Okay, so this is going to be our major product, and the below here going to be the minor product. Okay, so it is a similar step as one you have learned in the chapter of alkene. Now we're going to move on to the next synthesis, which is the number 3 here, which is the synthesis of the Grignard reagent. So Grignard reagent can be prepared by the reaction of haloalkane with the magnesium metal in the anhydrous ether, or known as the dry ether, which acting as the solvent. So let's say if you have a haloalkane reacting with a magnesium metal in the presence of the triether as a solvent is going to produce a Grignard reagent, or known as the alkyl magnesium halide. So this Grignard reagent is a very powerful thing, as it can undergo many reactions that makes them a useful starting material. So the Grignard reagent can be used in order to produce alkane, alcohol, and carboxylic acid. So alcohol going to be having a primary alcohol, secondary alcohol, and tertiary alcohol. So Grignard reagent is powerful in order to produce these three stuff here, which is A, B, and C. Okay, but now let us focus on the preparation of the Grignard reagent first before we go into each of the synthesis. So in order to prepare Grignard reagent, first we're going to have a haloalkane reacting with a magnesium metal, and this is going to produce MgBr, because Mg going to be inserted on this side in the presence of the triether. Okay, and similar process if we have aryl halide. Okay, aryl halides means that it is an aromatic ring attached with a halogen. When it is reacting with a metal in the presence of triether as a solvent, we're going to produce aromatic ring with MgCl here, because magnesium going to be attached at this in the middle here. So magnesium going to carry a partially positive charge, and Cl going to carry a partially negative charge here. Okay, so both of these are known as the Grignard reagent. Okay, and as mentioned, the Grignard reagent can be producing three important stuff, which is alkane, alcohol, which is primary, secondary, and tertiary, as well as the carboxylic acid. So now we're going to focus on the preparation of Grignard reagent in order to produce an alkane, which is A here. Okay, in order to produce alkane, first we need the Grignard reagent to be hydrolyzed with warm water in order to produce an alkane. So let's say if we have a Grignard reagent in the presence of water at acidic condition, what we're going to do is that we're going to remove the MgBr and replace it with H. And this is going to produce a byproduct of MgOHBr. Okay, so another example here, if we have the ethyl magnesium bromide. So we have ethyl MgBr here, and then when we apply it with water at acidic condition, what we're going to get is we're going to remove the MgBr and replace it with H. So what we're going to get is an alkene, which is an ethene. Okay, and the side product that we're going to get is MgOHBr. Alright, so this another example is also shown here. Let's say if we have the cycloalkane attached with MgBr. So this is also known as a Grignard reagent because it has a general formula of RgMgBr. When it is reacted with water at acidic condition, what we're going to do is we're going to replace the MgBr with H, and this is going to produce an alkane. Okay, so it's going to be methyl cyclohexane. Okay. Okay, same goes to this situation here. So we have the propane attached with MgBr. So when we apply it with water at an acidic condition, also we're gonna have an alkane where MgBr here gonna be replaced with hydrogen. So it becomes CH plus H gonna be CH2 as an alkane. And the side product here gonna be MgOHBr. Okay. Now we're gonna focus on the synthesis P. Okay, synthesis means that it's gonna produce a primary alcohol. So from the Grignard reagent, we can produce primary alcohol by reacting it with methanol. Okay, and this going to have another step, which is the hydrolysis step, in order to produce the primary alcohol. So first, we're going to start up with a Grignard reagent. So R here refers to the alkyl group. So this is the general formula, and this refers to the methanol. Okay, C double bond O, H and H. So here is the methanol. Grignard reagent reacting with methanol, you're going to produce RCHHOMgX. Okay, And this is because MgX going to attach at O and R going to attach at this point here. Okay, and it will undergo another step, which is the hydrolysis step. So hydrolysis means that it's going to have water and at acidic condition. So what you're going to produce at the end is that MgX here going to be removed, and we're going to replace it with H, where we're going to produce a primary alcohol of H. So this is known as the primary alcohol because the OH here going to be the carbon that attached to the OH only have one alkyl group. So it is known as the primary alcohol. Okay, and this is how you're going to produce a primary alcohol by reacting the Grignard reagent with methanol followed by the hydrolysis step, and this is going to produce a byproduct of MgOHX. So this is the general example. Now we're going to look into the specific example. Let's say our R here going to be CH3. Okay, so the same thing, Grignard reagent reacting with methanol where carbonyl attached with two hydrogen. We're going to produce the but now we're going to straight away use this the hydrolysis. So what we're going to get at the end is that we're going to get alcohol at last for our answer. So the CH3 going to be attached here and OH going to be attaching here. So this is going to produce a ethanol, which is our primary alcohol. OH, this carbon, right, only attached to one alkyl group, so it's a primary alcohol. Okay, in the previous slide I shown that step by step from one step to another step, but for this case it basically on one single step, and that is why you can write your product straight away. Okay, now if you have the same Grignard reagent and reacting it with methanol and you react it with H2O and H plus, the same thing, you're going to get a primary alcohol. So here going to be your R group and it's going to be attaching here, and this carbon double bond with oxygen going to break apart and bond hydrogen on the oxygen, and this is going to produce a primary alcohol because carbon here attached with one alkyl group, and the side product here going to be known as MgOHBr, and the name of this compound here going to be cyclohexyl methanol. Okay, now we're going to look into the synthesis of secondary alcohol. Similar step as before, the Grignard reagent, in this case the Grignard reagent need to be reacting with an aldehyde. Okay, tadi untuk primary alcohol dia kena react dengan C double bond O, H dan H. Tapi untuk produce secondary alcohol, your H here you're going to replace with one alkyl group, and this is known as aldehyde. Okay, so when you react Grignard reagent with aldehyde, what you're going to get is R1 C R2 OMGX, yang mana R1 going to be attached at this side and the MgX going to be attached on the oxygen part here. And then we're going to undergo hydrolysis with H2O and acidic condition in order to remove MgX and replace it with hydrogen here. Okay, and this is going to produce a secondary alcohol because the carbon that is attached with the hydroxyl group is attached with 1 and 2 alkyl group. So when it is attached with 2 alkyl group, it is a secondary alcohol. And the side product that we are producing is MgOHX. Okay, so this is the step by step. Okay, now we're going to look into the specific example. For example, our R is the general, but now we're using the ethyl MgBr here. Okay, and it is reacting with a methanol, with an aldehyde, sorry. So our R here also becoming an ethyl group. Okay, so Grignard reagent reacting with aldehyde in the presence of hydrolysis. So it is one straight step. So what we're going to get is the product straight away. So what we're going to get is CH3CH2 attaching in this side, and our oxygen here going to become OH. So CH3CH2 attaching on this side, and then CH2CH3 on the other side, and O here become OH. So this is going to produce a secondary alcohol because the carbon here going to be attached with 1 and 2. So secondary alcohol. Okay, and this is known as the 3-pentanol. Alright, and the side product here going to be MgOHBr. Okay, another example, but now using a cyclic Grignard reagent reacting with aldehyde. So what you're going to get is this R group here going to be attaching on this side, and the OH here going to be break apart. So this happened via hydrolysis at acidic condition, and this is going to produce another alcohol, which is also a secondary alcohol because the carbon here attached with 1 and 2 alkyl group. Okay, and the side product here going to be MgOHCl. Alright, so now we're going to produce a tertiary alcohol. Okay, so tertiary alcohol, we need to react our Grignard reagent with a ketone followed by hydrolysis in order to produce a tertiary alcohol. So let's say if we have our Grignard reagent, but now we are using a ketone because the carbonyl is attached with 2 alkyl group. Okay, and the same step as before. This is shown step by step where the R1 going to be attached at here and O going to be attached with MgX. Now we will undergo hydrolysis with water, H2O, and acidic condition. We're going to have R1, Cr2, R3, and MgX here going to be changed with H, which refers to a tertiary alcohol because the carbon here going to be attached with 1, 2, and 3 alkyl group. So it's going to be a tertiary alcohol, and the side product here going to be MgOHX. So this is the general idea. So this is going to be the specific example if we change our R to become ethyl. Okay, and here we are using ketone, not an aldehyde because it is attached with 2 alkyl group. Okay, so we're gonna get into the product straight away because we do that in a single step where this happens at the hydrolysis part. So the CH3CH2 gonna be attached here, and the O here gonna become OH with a single bond. Okay, so once you do that, you will get CH3CH2 dash C refers to the middle, will have CH3 and CH2CH3 at the end here. So this carbon here is a tertiary alcohol because the carbon attached with 3 alkyl group. Okay, and this is going to produce a side product of MgOHBr. Okay, now we're going to look into another example of Grignard reagent reacting with ketone which have a cyclic compound. Similar step. So you have a hydrolysis at acidic condition. So the CH3 here going to be attached at this side, and the double bond here going to be a single bond with H. Okay, so this is going to be your product. Okay, so here refers to a tertiary alcohol because this carbon here attached with 1, 2, and here is also refers to another carbon. So we're going to have 3 carbon attached to this, and this refers to a tertiary alcohol. And the side product here going to be MgOHBr. Okay, and this is the summary of what I have talked just now. So from a Grignard reagent, it can react with methanol in order to produce primary alcohol. The Grignard reagent can also react with aldehyde. Okay, aldehyde here, in order to produce secondary alcohol. And the Grignard reagent can react with a ketone with hydrolysis in order to produce a tertiary alcohol. If it is reacting with methanol, where C double bond H and H, it's going to produce a primary alcohol. So look into the electrophile or the reactant that is given. Alright, so H and H. This one only got one H. This one doesn't have any H, all the alkyl group. Okay. Now on the last part, which is the synthesis of the carboxylic acid. So the synthesis of carboxylic acid is we're going to react our Grignard reagent with carbon dioxide followed by hydrolysis to form the carboxylic acid. So similar step as before, Grignard reagent reacting with carbon dioxide, which can also be represented by OCO, which refers to CO2 and also refers to carbon dioxide. So when we react them together, what we're going to get is R here, and the oxygen here going to be attached with MgX. Okay, and then we can undergo hydrolysis at acidic condition in order to produce carboxylic acid. So this, as I mentioned, is a step-by-step process. And the side product here going to have the MgOHX. Now we're going to look into the specific example where our R group here going to be CH3CH3. When the Grignard reagent is reacting with the carbon dioxide, we're going to produce the first step here, which is OMGBr. So the same thing here going to be attaching with the R group here, and then the O here going to be attaching with the MGBr. And when we undergo hydrolysis, it's going to produce the carboxylic acid, where MGBr going to be replaced with hydrogen. And the side product here going to be MgOHBr. Okay, so this is a step-by-step. But now, when we have our Grignard reagent reacting with carbon dioxide, straight away with water and hydrolysis with water and acidic condition, we can straight away produce our carboxylic acid. Okay, and as you know that MgCl going to be removed and replace it with COOH. Okay, and the side product here going to be MgOHCl. Now, if we look into another example of the aryl halides or the aryl Grignard reagent, where it is attached with aromatic ring, when it is attached with the carbon dioxide followed by hydrolysis, what we're going to do is we're going to remove the MgCl and replace it with the COOH, which refers to the carboxylic acid. And the side product here going to be MgOHCl. Alright, and these are the summary that I have talked just now. So when Grignard reagent reacting with carbon dioxide with hydrolysis, we're going to produce a carboxylic acid. Okay, and the other thing that you need to know is that there will be an increase of one carbon chain. So from 1, 2, 3 and one subsequent, 1, 2, 3 and one subsequent, we're going to get another increase in the carbon chain. Okay, so Grignard reagent is a very powerful method in order to increase the carbon chain and in order to produce alkane, alcohol, which is primary, secondary, and tertiary, as well as the carboxylic acid. Okay, so I think that's all for today's video. See you again some other time. Bye!